1 minus cosine x over sine x. Yes?
What happens to the x over 2?
That's what that means. This is equal. We proved it when you weren't here on that video, or in the notes, because we didn't have a video that day. We actually proved that this is, we didn't prove this one. That one is on that. Did you get the sheet that has all your identities on it? Did you print that off at all?
Yeah, I think so, yeah.
I'll hand you one. We have more otherwise, but it actually shows you what proves. This is equal to this, all right? Nothing disappears. It's just built into that. Okay, so the only thing I've left is cotangent. The problem with my cotangent x over 2 is if I look at my identity sheets, I don't actually have one that actually says cotangent. So then we have to go back to the definition of cotangent. Yeah? It's just the inverse or reciprocal, so we can just flip what we have here. So if tangent x over 2 equals 1 minus cosine x over sine x, we can rewrite that using cotangent, and just rewrite as cotangent x over 2 is equal to sine of x over 1 minus cosine of x. And I'm going to rewrite this one as well. I have cotangent x over 2 equals 1 plus cosine of x over sine of x. Now I could do a reciprocal here, but I don't feel like it because I know I'm not using that one. So I just flipped them. All right. Which one looks like it's the easiest to use, knowing that we're going to be adding these things together, and if we have a common denominator, our life is a lot easier when combining stuff. So which one of those two would I use, do you think?
Probably the bottom one.
Probably the bottom one. Because the bottom one has sine x on the bottom, which will be perfect because we're adding. So we'd have 1 plus cosine of x over sine of x. And since we're adding and we have a common denominator, that means we can just push the tops together. You could probably do this in your head. I'm just going to do it all the way. So I have 1 minus cosine of x plus 1 plus cosine of x all over sine of x. Well, my cosine and cosine are going to cross each other out, and we're going to have 2 over sine of x. And that's equal on either side. And even if I didn't work on the other side, I could work my way backwards. I could say this is 2 times 1 over sine. Well, that's 2 cosecant x. So you could just work down one side at a time. Sometimes it's nice to look at what side this can also look like. So I had multiple options that this could look like. So sometimes if you have a couple options to look for, you'll catch it before you continue to do more work when you didn't have it. Okay, questions on that one? Okay, I want to talk just a little bit about that big problem. Because this one's a lot bigger than really... I think we made it a little more complicated than it has to be. All right? So the whole goal of these are just to use the double or the half identity to either get sine alpha or cosine alpha. Okay? Because as soon as we got cosine alpha, I'm not even going to look at the next slide because that was more just for notes, and that's why we did it. The easier way to do this is as soon as I knew cosine alpha equals negative square root of 17 over 17, what probably the next easiest step to do is just saying, well, cosine squared alpha plus sine squared alpha equals 1. Then I could have just plugged in that negative square root of 17, I think it was over 17, squared plus sine squared alpha. I would just subtract this from the 1. I'm sorry, that equals 1. I would have subtracted this from the 1, and then I would have taken the square root, and I would have been done. Okay? So don't continue to use the double angle or the half angles just because it's in this section. As soon as you know cosine alpha, or even sine alpha, there's somewhere you'll already know sine alpha. As soon as you know those, use this to get the other one, and then tangent is just putting sine over cosine. Okay? So realistically on this problem, the only time I had to use a half identity was here to turn that 2 theta or 2 alpha into just alpha, and in fact this is the only step I actually needed that. This step I use cosine squared plus sine squared equals 1, and that third step down here could have been cosine squared plus sine squared equals 1. Alright, so usually you only need to use a double or a half identity once. Okay? So hopefully that makes it a little clearer. And you also don't have to do all this full simplification if there's square roots in it. In fact, in the book, I think the book would have left this as 1 over square root of 17. Alright, they'll just leave this as 1 over square root of 17, so you don't have to worry so much about multiplying the bottom and top by a square root. Alright, so don't focus on doing that. Just leave it as 1 over square root of 17. You'll be fine. Okay? Alright, any questions for me? Like whole class questions, not what did I do here? Okay, then go ahead and get started. If you are done with all your homework, you can